And let me just read the problem again. If each drum had cost $5 less. So the D doesn't stand for dollars, it stands for drums, which is kind of complicated because you have dollars, which are down here. So these are the dollars, these are the dollars, and these are the drums. All right. And then it says if each drum had cost $5 less. So it's going to be, the drums would be X minus 5 on the bottom. And each drum, okay, so the drums would be on the top. So that doesn't change, but each one, the rate now changes because it's going to be $5 less. How many drums, that would be the number of drums, could you get for $100? So this is the number of, down here is dollars, these are, and you want dollars. So everything needs to be flipped around. I don't have it where things cross out right. So I'm going to flip everything around, I do believe. So you want to end up with dollars. These are drums up here. These are drums, and these are the dollars, right? And this is going to be drums. So I need to have it so that the dollars are on top. So it's going to be, these are like unit multipliers. So the dollars are going to go on top, the drums on the bottom, times the number of drums equals the number of dollars. So then we're just going to get, we have to multiply both sides by the reciprocal, so it's going to be n over x minus 5. I made this one just like the one on the test, like it's almost exactly like the one on the test. So these will cross out. So the number of drums is going to be 100d over x minus 5. Okay. You're almost right, Claire. 100x. Well, yeah, if you would have made, if this stood for x, but you can't have two x's in your problem. So it'd be the number of drums. Let me find the test. I was going to scan it, and then of course my scanner doesn't work. Hold on. Let me see if I can find the test. Okay, it's almost exactly the same. So if you understand this, you're going to get this one right. So the reason, initially I put the rate like this because I didn't know which way I was going to use it. And then I found out that I want dollars, so I had to put the drums needed to cancel out. So I had to flip it right here. So this would be drums, and this would be drums, right? And they would cancel each other out, and we'd be left with the dollars. If you have questions, go ahead, use your microphone if you have questions. I know these are hard. But this is the number of drums. I used 10. On the test, it's the number of microscopes. So you could use N for that as well. And it's going to be $20 less per microphone, so you're going to subtract 20 this time. And it's going to cost $2,000, so you're going to put 2,000. So make sure you get it down. Really what you want is x minus 5 over d times n equals 100. This is the equation you're going to use. Yeah. Okay, you ready? Number 2. Number 2 is from, I'll just write it down. I have the sheet somewhere here. Let me just go back here. So number 2 is lesson 40, number 1. So go. How old are you with us? I hope everyone has their book. It's hard without your book. Let me know when you got this one. Okay, Claire has got the right answer. Good job. Okay, for this one, you could use radians, but we're not comfortable with those yet. So this is, a circle is 360 degrees. Well, that's close, Calder. Okay, let's see. So a circle is 360 degrees, and we are going to we have 35 out of those 360 degrees, right? And then we have, if we're going to find the circumference, because we want to know this distance, you use radians. Okay, you go, Claire. Okay, it'll be good because we're going to be doing wheel problems. We're going to use radians. So it's good to use radians. I like using the degrees. I think it's easier. But you would have just put 2 pi down here, right? Instead of 360. Oh, use pi over e. Interesting. But you got the right answer. Okay, so this arc right here is out of the whole circumference. Oh, okay. Well, let's see. So if you had a whole circle, we would find the circumference. The circumference is 2 pi r, and r is 30, right? But we're only wanting 35 360ths. So if we multiply all this out and divide by 360, which I did, and I got 18.3333 feet. Mercedes, did you find what you did wrong? Calder? Did you do what I did? So, okay. All right, Mercedes, do you understand what I did? Wonder what the answer book uses. 40, number 1. They use radians. They use pi over 180 times 3. Interesting. Okay. Mercedes, you good? Can't tell. You can do it that way. Here's the other way to do it. 35, this is the way that Claire did it. Like this. So then you get 35. This is more comfortable for you guys. Pi over 6. This goes in 6 times. Well, it doesn't go in 6 times. It reduces. And then you would get 18.33 feet. Is that how you were doing the Mercedes? I was just using my old common sense. Finding the circumference and then taking the fraction of the circumference. Instead of really using the advanced math. Okay. All right, you're close. All right, you ready for the next one? Here we go. So that one is just like the one on the test. One of the tests is a horse is galloping instead of a dog. So really similar. Should be able to get it right. Okay, next one, lesson 42. I have on the study sheet 8 and 9 because there's multiple ones. This is sketch the graph. We only need to do one of these. So go to lesson 42, number 8. Because I'm going to talk about the one on the test. So go ahead and graph that. you're doing these, you don't need a lot of points. 3 points are sufficient for this. Hey, did you guys get that? Nice. Okay, I like that. I can see Claire's very good. Okay, Mercedes, did you get this? Alicia's missing out on this. Okay, so you just need a few points on here just to see, like, if it's a, usually if it's a fraction, it's going to go the other way. 1, if I put a 0, always try to get the 0 1 point. So if I put a 0 in here, 1/2 to the 0 is 1. If I put a 1 in here, I get 1/2 squared to the second power squared. Now, what if I had something like this, because this is more like the one on the test. It's not exactly like the one on the test, but it's more like the one on the test. Hold on, I have a delay. All right. To the negative 2x power. All right, if it's to the negative 2x power, let's table values and see what that one's going to be, because the one on the test is negative. So we may as well practice this one. So go ahead and do this one. Instead of doing number 9, we'll do this one. Why? No, just put the numbers in there. You only need 3 numbers. You don't have to worry about simplifying it. If you want to simplify and you get the same thing, that's fine. But I'm just going to put in the same numbers and see what I get. Working along with us, Calder? Okay. You can check your answer with mine. When we have the negative number, it's going to flip. Look at that. We're still not going to get a negative. Remember, if I put this, if I did 1/2 to the negative 2 power, it's the same as, we can flip it, it's going to be 2 squared, which is going to be 4. You could have taken this whole thing and written it as y, and maybe this is what Claire wanted to do, to the 2x power. Yeah, you could have done that. That's fine. Either way. Okay, so the one on the test is really similar to this one, not exactly, but really similar. So when you get to the test, this is how, like, I like to do the SAT practice. I like to have everyone do all the tests in the book, because then when they go to the SAT, they're familiar with everything. Okay, you ready for the next one? All right. Mercedes, you got that one down? Okay, all right, that helps. All right, the next one, this is a number 4. Are we? Yeah, we're on number 4. So number 4 in the study guide is lesson 41, number 8. You never did this one because it's an even on an odd lesson. 41-8. You only need to do one of these. There's 2 of them. Just do A. Okay. All right, good job. That one wasn't too bad, right? So you have to know the formula. If you don't know the formula, you're in trouble. It's 10 things taken 4 at a time. It's a permutation. So you just fill it in. This is your N, and this is your R. Kind of important you know which are which there. It's in alphabetical order. N comes before R. So we're going to have 10 factorial over 10 minus 4 factorial. So you get 10 factorial over 6 factorial, which is 10 times 9 times 8 times 7. The 6 down cross off. You multiply that in your calculator, and you get 5,040. So when you come to that one on your test, you can feel pretty happy. There's actually 2 of them, and they want to know which one's bigger. So you do both of them, and then you subtract them. Okay, now we're moving on to some logarithms. We're covering everything under the sun on this test. So there's some really easy things and some really hard things. All right, the next one on the study guide is lesson 40. And it's actually numbers 7 through 10. It's all of those because there are A, B, C, 3 of them. There's 3 different kinds. So go ahead and start working those. This will take a little bit of time. I'll start working them up here too, and you can look when you're done. Hey, how'd you guys do? Did you get those 2? 14. Oh, you already got the next one. Okay, you go, Claire. You're ahead of me. All right, number 9. 9 is 3 log c of x equals log c of 27. Claire, do you like logs? Seems like you know how to work them. And then number 10. You guys are going so fast. All right, we'll slow down a little bit. Wait. Oh, this is, did you get number 10, Claire? You know how to do it? Go ahead and try it. Calder, how you doing? And does anyone need any explanations for any of these for? Because I just kind of wrote it all up. Okay. Well, I didn't know that because I can't see you. So, Mercedes, are you getting these? Okay. So 10, pretty much if you have like log base 3 of x equals log base 3 of 5, something like that. When these are the same, these have to match. So x has to equal 5, right? Now, this one, the 2/3, when you have a number in front of the log, it pops up as an exponent, so it becomes 27 to the 2/3 power, right? Just like in number 9, we popped the 3 up as an exponent on the x and made it x cubed, right? So if it's in the front, it pops up as an exponent, and then you set the 2, they're called arguments, equal to each other. So I popped the 2/3 up as an exponent on the 27 and got this. Now these bases are the same, so now I can say x equals 27 to the 2/3 power. But what is 27 to the 2/3 power? It's the cube root of 27 squared. Let me see if there's any this hard on the test. No. I made one. The one in the book's way harder. Test ones are fairly easy, a little bit different. I might not have picked exactly the right problems. It's hard to find the exact right problem. So does that make sense, Mercedes? Okay, let's go on to number 9. Or not number 9, I don't even know what number we're on now. We are on lesson, this is number 6. So 6. It's lesson 34, number 13. So go. Ah, these are fun. Right. I was wondering. I'm getting ready to help you with this. I'm just going to write all these up. So you definitely need to have the first section of your unit circle memorized, right? And then they just repeat the whole way around, so they just change signs. So, whoops, you should write them right. Square root of 2 over 2. How about you, Mercedes, with these? Okay, I didn't leave myself much room here for this. So this one's going to be 1/2. I move this down a little bit. Ooh, look at that. Okay, 1/2 square root of 3 over 2. Okay, so these are the sine and cosines of the angles 30 degrees, 45 degrees, and 60 degrees. We all get that, right? We're good? Now you need to know the tangent of each of those, which is y over x. So you need to, it's pretty easy, y over x on the first one. I'm going to leave it unrationalized. So if I took y divided by x, square root of 3 is going to, it's going to be 1 over the square root of 3. Okay, go ahead. So this is the tangent of that one. The tangent of this one is 1, and the tangent of this one is the square root of 3. So those are all the tangents. You should have those. I mean, you don't have to memorize them. You can just figure it out because tangent is y over x. Okay, so whenever you see arctangent with the capital A, it's going to be the angle whose tangent is 1. So that's what that means, the angle. The angle. DA, see the big A? Angle, whose tangent is 1. Now, when you're doing the arctans, just in arc cosines and all those kind of things, it's going to be the arcsine and arctangent are going to be in these two quadrants, and the arccosine are going to be in the first and second quadrant. So the arccosine will be here. The arccosine. My pen is having a little bit of difficulties today. Arccosine. All right. All right, so what I did while you're gone, Mercedes, is I wrote all the tangents up there, which is just y over x. So if you have these memorized, it's not a lot to memorize. It's really easy because they repeat in all the quadrants, except remember we do, all students take calculus, so they're all positive in this quadrant. The sine is positive in that one, the tangent is positive in that one, and the cosine is positive in that one. All right, so we want the arctan of 1. So look at that, there's 1 right there, right? The angle that gives that to you is 45 degrees, so the answer is 45 degrees. Okay, did you get that, guys? The angle whose tangent is 1. If you have them all written like this, it's not so bad because you can just look up here. Oh, this one's 1. If I would have said the arc sine of 1/2, no, yeah, 1/2, what angle would you say? The arc sine of 1/2, what angle would that be? Yeah, because here's the sine. None of these have a 1/2, and the angle would be 30. So the arc thing just means what angle. Now, when you hit these two messy guys, it's not as easy. You have to build the triangle. Remember these? We build the triangle. No one loves these except for me. Okay, so you take and you build the triangle. So here we go. I'm going to build it. Build the triangle, and the angle will come. Okay. When you build it, you have to remember that this is y, this is x, that sine is y over hypotenuse. So your y is going to be 3, so it's going to go up to 1, 2, 3, and your hypotenuse is going to be 5. You just kind of fake it in. You don't really know what it is, so I call it faking it in. So I kind of got the y right. So the y is 3. The hypotenuse is 5 because sine is y over hypotenuse. And then you Pythagoras theorem it, and you get 4 for this one. All right, so you built the angle. Now with that angle, oh good. I thought this hit you last time. Didn't you just have a revelation last time? No, that was somebody else. One of my other classes. Okay, maybe it was you. Okay, now we're going to find the tangent of the angle that triangle built. So tangent is opposite over adjacent. So the answer is 3/4 because we wanted the tangent of this angle. Tangent is opposite over adjacent, so the answer is 3/4 for that one. Okay, I'm getting pretty messy here. I think I'm going to erase everything and build, well, I guess I don't want to because I want to keep that little thing up there. I just made such a messy problem. Okay. All right, cosine of arctan of -3. Yikes, what do we do with that one? Okay. I think I'm going to erase well, let's see if I can go down here. Yeah, let's just go down here and rewrite that one. So that's the cosine of the arctan of -3. All right, so a little creepy, but put this over 1, and you know tangent is y, my pen has a delay, over x, all right? So we're going to build a triangle. Now the y is going to be negative, so a little bit trickier here. So here we go. Build the triangle. When you have these bracket things, it means build the triangle. So here we go. Your y is -3, so I'm going to go down 3. 1, 2, 3. And your x is 1. So the triangle is going to be I made it kind of little. Looks like that. So this is 1 and this is -3. We need the hypotenuse because we're going to be using cosine. So we have to use the Pythagorean theorem. So it's going to be 1 squared plus -3 squared equals c squared. And we get c squared equals 10. C equals the square root of 10. So that would go right here, square root of 10. So this is our theta. So we build our angle. So now we don't care about this. We build our angle. We want the cosine of theta. Cosine is adjacent over hypotenuse. So this answer is going to be adjacent, which is square root of 10. Nope, is 1 over the square root of 10. And then we rationalize it, right? You don't want to leave it illegal. And so you get square root of 10 over 10. Okay? That was a little tricky. Let me look on the test. I'm going to help you a little bit on the test. So I'm gonna have to go. Because I didn't give you any quadrantal angles. So here we go. I'm giving you like bonus help. You guys ready? Gone. Okay. How would you do something like this? It's not exactly like the test, but it's pretty doggone close. The arc cosine of -1. So I erased all the stuff I put up there with all the angles. That says find the angle whose cosine is -1. Can you guys do that? Can you find that? All right. I gotta rebuild this. Now, none of these, I don't even need to put these there. You guys have them. But none of these have a cosine of -1, right? This one was square root of 3 over 2. This one was square root of 2 over 2. This one was 1/2. So this is a quadrantal angle. So if you put the points on here, I'm really I can't get this built in my head. I have to draw it every time. This is 0, 1, right? This is 0 or -1, 0. And this is 0, -1. All right? So cosine of -1 would be this angle right there because this is your cosine, and this one's your sine. So your answer would just be 90 degrees. That is it. All right, what if I said the arc sine of 1? Whoops, 180. Nope, you're right. I don't know my angles yet. 180 degrees. Yeah, the whole way around is 180 degrees, or that far. Okay, what if I said the arc sine of 1? What would that be? That would be 90 degrees because here's the sine. So if you have a sine or cosine of a 1 or -1, it's going to be a quadrantal angle. Okay? All right, that was your big hint because I didn't give you a problem like that. All right, next one. We have, cross these out in the study guide. So we did 1, 2, 3, 4, 5, 6, 7. Wait, 180? Oh, shoot, I just erased everything. What was it, Mercedes? Was it the arc? Did I do the arc sine of 1? Was it the arc sine of 1? Okay. I'm scribbling it on here now. This would be 1, 0. Oh, you are so, well, no. This is 0, 1. So the sine is the second one. So I actually got this one right, I think. You see that, Mercedes? This is -1, 0. So this would be cosine, sine, like that, right? So if we're saying the arc sine, we're saying what angle is at 1 where the sine is 1. It would be right here at 90 degrees. Wait, something's not sinking in, I can tell. That's why I like seeing your faces. Okay, so the previous one was the arc cosine of -1. It's where's the cosine -1? Well, here the cosine's -1, and that's 180 degrees. Here the sine is 1, so it's going to be 90 degrees. All right, you good? Now, tangents are tricky. Tangent, some of them are undefined. Like this one would be 0, -1, and tangent is y over x. So at 90 degrees, which we're going to be graphing tangent curves, it's going to be undefined at 90 and 270 degrees because you can't divide by 0. And the tangent of 90 or 0 and 180 is going to be 0. All right, make that all work in your head. Okay, where did we leave off? Did we do 4314? I'm just trying to see where we left off. We left off at 34. Okay, we're on 4314. Okay, good to know. 4314. And this is only problem 7. Some are easy. You'll see it coming down. So go ahead and do that one. All right, the directions are simplified. All right, someone already got me a number. Let's see if I did this one. All right, anyone else get that? So when you have these two things match, you just get the exponent because it's going to be 1. These two things match, so you're going to get a 3. These two things match, so you're going to get a 4. So the answer is 1. Those are fun. When the base matches the base, you get 1. Hey, Mercedes? Okay. Calder, how are you doing? Okay. Number 8. Lesson 43, number 16. Okay, another log problem. This is a log equation. A log test. Hey, Mercedes is on this. Good. Make sure you don't get any negative numbers in your arguments. If you do, it's no solution. Okay, Claire, you got that one? Okay. All right, let's see what the next one is. It's lesson, I have 2 problems here for this one. I don't know why. Lesson 27, number 15. So let's see what that one is. Okay, whatever. 1 is enough for these. Okay, you have to find the domain. Oh, yeah, all of them. Sorry. On the test, there are 2. No, there's only 1 on the test. But it's like everything. It has all of these things combined. It's a nightmare. The first one, x has to be less than 3. Because it has to be greater than or equal to 0. Or 1/3. Yeah, 1/3. This is an algebra 1. I messed up. Okay, 1/3. Yeah, good. So if it's a square root, make sure you set it greater than or equal to 0, and then solve for x. This, if you just want to write it like this, that is fine. They do some crazy stuff. If you were writing this in real life, like if you went to college, they would write it like this. They would write negative infinity, comma, 1/3. Then they would have the brackets are wrong here. If you were writing in this in college, they would have open circles. It would be negative infinity, comma, 1/3, parenthesis. All right, you guys are already working on B. You're way ahead of me. and not equal to. With all real numbers such that, I forget how they write that now because I never do it. All real numbers such that x is less than or equal to 10 and x cannot equal 2. Like that. If you just put it like this, it's totally fine. Okay, and then C is, you need to do that because the problem on the test is a combination of like B and C. C. It is a negative 10. And this is a 1. I don't know what I'm doing today. Hold on. Okay, this should be, so x cannot equal negative 3 and 1, and this is a negative 10. Because if you subtract that, is it? X is greater than or equal to negative 10. Yeah, duh. Okay, all right, let's go on to the next one. Lesson 37, number 9. Oh, this is a fun one. Okay. Okay, good. Okay, next. We are over halfway done, which we hopefully will get done with this whole thing. So number 11 is lesson 23, number 12. Never mind, that doesn't seem right. Find the domain. Hold on a second. Test 11. Oh, I have to change this for my other class because this is not right. I'm just going to make one up for you guys. So it's not number lesson 23. It must be another lesson. Hold on. That lesson. See if I can find it in the book. Number 2312. Nope. All right, let me make one up. 33? Lesson 30? Lesson 33, maybe. Let's see. If it's not there, I'll just change the number of the one on the test. Nope, be nice, because that was a fun one. Okay, so here you go. Skip this one. Let's do the one that I make up for you. Then I need to go find this one. Okay, I want you to sketch the graph of these functions. So f of x equals the absolute value of x plus 2 plus 1. Sketch that graph. done? Just trying to fix my mistake here. Oh, I see. Okay. Okay, let's try this one. If you know what an absolute value function looks like, it's going to look like a v, right? And if it was just like y equals the absolute value of x, it would just be on the x-axis at 0, and it would be right on the origin. That's what it would look like if it was like this. But we have a plus 1. Whoops, I thought I was drawing a line, and I drew a freehand line. Okay, so that would be what it would look like, but it's going to shift up 1 because this is the vertical shift, and it's going to shift to the left 2 because if it's inside the absolute value, it's going to go 2 to the left. So we're going to go over 1, 2, and up 1. So your vertex is going to be right there. And it's still going to be the same V. It's still going to go up 1, over 1. The shape of the V hasn't changed. And so it's going to look like a V right like this. So you're basically taking this, you can just look at it, you can either plot points and do this, but you need to recognize that absolute value functions are V's, and when it's inside the absolute value, it shifts it left or right, and if it's outside, it goes up or down. Okay, is that what you got, Grace? I mean, Claire? Why did I call you Grace? I need to fix that one. It was definitely from lesson 22, but they don't have any examples like it. Weird. Okay. All right, I want to do one more of those for you because they're kind of tricky. All right, this is another one. Number 11 on the test has 2 parts. So g of x, let's see if we can do this one, equals 1 over x minus 2, whoops, x minus 2 minus, let's do plus 1. So what would that one look like? You might need to plot some points on that one. If you do it like the book does it, it's ridiculously bad. Actually, let's do this one together. I feel bad for my other class because I put the wrong one on. Second of all, these are really hard. Okay. So are there any values that x cannot be? Think about it. I think I need to change this problem, guys, because yeah, I know. This one's different. Hold on, I'm going to change it up. I'm going to make it more like the one on the test. We'll make this a plus 2 and this a minus 1. Now it's really close to the one on the test, but not quite. Okay, now there's some numbers that this can't be. If x were going to equal -3, we're going to get -3 plus 2 is going to be -1. The absolute value of -1 is +1, and then 1 minus 1 is 0. So even though this one's absolute value, it's not going to look like a v. I know it's going to throw you a little bit. So we're going to go over to the x is -3 like this, and we're going to drop an asymptote because it's illegal. Remember we did these before? If something makes the denominator 0, we can't do our graph on top of it. There's one more value it can't be. What else can't you put in here? X cannot equal -3 and x cannot equal, this is what it comes to when you have to find the domain. It seems dumb, but for graphs you need to know that. Right, x cannot equal -1. So we're going to put another asymptote down -1 like this. Alrighty? Okay, now we have to pick points. So, just we want to pick a point here, here, and here. just to see where the graph is going to be. There's no way that the y can ever be 0. There's nothing you can put in here to get the top 0, right? So it's never going to cross over the x-axis. So let's just put in a couple points. Let's put one in each one, x and y. So if we put in a -2, that's a good one, right? -2 plus 2 is 0. So 1 over -1 would be -1. So we're going to put a point. Oops, I picked one in the middle. So -2, -1 is going to be down here. So the graph right there is going to look like this. Whoa, I'm really bad at drawing on this thing. So that's going to be that graph. You could pick some more and prove it, but we'd be doing fractions. Okay, then let's put 0 in for this one. We put a 0 in, we're going to get 1. So it's going to be 2 minus 1 is going to be 1. So if I put a 0 in, I get a 1. So it's going to look like this. Because remember, it can never cross over the x-axis because there's no way to make it 0. And then we pick one over here. Let's pick 4. So we're going to get 4 plus 2 is 6, minus 1 is going to be 5, so it's going to be 1/5. So the key for this one is it's going to be in this quadrant little thing. It's not really a quadrant, it's like more than a quadrant. It's going to look like this. So the one on your test is almost identical to this one. So you want to figure out what x can't be, put asymptotes, and then pick points in each of these sections. And it's going to look like this. It's going to be a little bit different, but it's going to look like that. Okay? Whew, that was tricky. Okay, next one. Lesson 37, number 6. Okay, so this is one of those equidistant ones. So go, see if you can do it. These are pretty easy. You know what to do. Remember these? You guys getting it? answer right there. Okay, good.
How far away does she live?
Good. That one should be easy on the test. You just do 2 distance problems, put those numbers in. I like that. Okay, Mercedes, you good? They look like they're positive according to mine, don't they? Oh, this 10 should be positive. Wait a minute. Yeah, this should have been a positive 10. Wait, -6. Wait, I'm trying to see what I did. They are negative, because I compared my answer to the book. Let's see, this is -14. This would be -10y. I think they're positive. I think they're negative. Let me just go back up here and redo mine. Oh, it's 9. Okay. What's 9? The 9? Okay. Yeah, the answer is what I had it, but some of the work I did was weird. Okay. So, yeah. What do we have from here? Let's see. -6x. These 9s would cross out too. Make it easier. These y squareds would cross out. -6x. I think I was trying to just rush us through this. 4y plus 4 equals 8x. Mercedes, do you see the positive, that they were negative yet? -14x. Okay, then I'm not going to keep going. All right, let's go to the next one. We're running out of time now. Okay, the next one is lesson 44, number 18. All right, determine whether they're inverse functions by computing them. This one should be easy. You have to do it both ways to find the inverse of it. Yeah, they are. Okay, so there's a couple easy ones on the test. I think that one's easy. I think summation one's easy. The equal distance line one's easy. Okay, Mercedes, you got that? Claire's moving at record pace here. Okay, we are on number 14 on the study guide. Lesson 42, number 7. Oh, this is an easy one too. So center 3, 4, standard form radius equals 3. Go. You guys stumped? So basically you have to memorize the equation for a circle. So the equation for a circle is x minus h quantity squared plus y minus k quantity squared equals radius squared. They're giving you the center of the circle, which is h and k. All you have to do is put it in where the h is and where the k is. I just put them in h and k, and the radius is r squared is 9. This should be really easy. This is something really to learn because it's all over the SAT. So memorize this formula. Really just the distance formula from the center of a circle to the point on the circle. HK always stands for the center. So HK is the center of a circle. And you just plug them in. So it's good we did the study guide. All right, are you befuzzled? Whatever word you used. Confuzzled. Are you unconfuzzled? Okay. All right, Mercedes, you good? Calder, are you alive? Okay. All right, we are on number 15. It's a proof. We're going to skip that one. I'm not going to do that. I'll give it to you. You can do that on your own. Well, let's write that one down. It's lesson 16. Number 11 is the one that it looks like. 16. We can look at it real quick. Way back in the day, number 11. So basically, you're going to prove two triangles are congruent, and then their parts are congruent. That's about it. On the test, it gives you two. It's really simple. It gives you two. You have to figure out two triangles are congruent by, they give you two sides. You prove they're congruent, and then you say CPCTC. The simplest proof ever. All right. All right, the next one, lesson 39, number 10. I'm getting there. Ooh, yikes. This one looks a little challenging. Hey, do your best. Go ahead, if you have your answer, I'm doing it. You got the square root 3 over 2. 39, number 10. It's actually not that. Did you guys change it in degrees? Probably, right? No? You did it with radians? Good job. Okay, so we know that 12 pi over 6 would be like a whole circle. So I'm subtracting off 12 pi from 13 pi, like this, basically. And I'm getting 1 pi, but it's going to be negative, so I have negative 1 pi over 6. You can turn it in degrees. The degrees would be 300 and, I think it was 390, and then you can subtract your 360. And then this one's 13 pi over 6. So you would subtract 13 pi over 6 minus 12 pi, and you would just get pi over 6, right? And these are both 30 degrees. So if you know your unit circle, you know where they're going to be. So the cosine of this is going to be square root of 3 over 2. And we have to decide whether if it's positive or negative. It's going to be positive. And then, wait a minute, the cosine of that would be negative. If I have the negative right? And then the sine of this would be 1/2. The sine would be 1/2. All right, do you guys get that? Mercedes, you're looking at me like you don't get it. So this would be negative 30 degrees. Cosine of negative degree. Oh, no, it is positive because it's the x coordinate. Yeah. Okay, so then we have to find the common denominator, which is 2, square root of 3 plus 1. And that's your final answer. Yeah. Because all students take calculus, it's in the C, and it's a cosine, so it's going to be positive. All right, what negative? This negative or this negative? So this is actually going to be negative 30 degrees right here, or pi over 6, right? If it's going to go this way, it's going to be negative. And this is all students take calculus, so cosine is going to be positive in this quadrant, and that's why I made it positive. It just went the negative direction. All right, good. Okay, we got to hurry up. What time is it? Oh, 4 minutes. Okay, we need to go to the next one. You guys can look at this one yourself because I just have on the study sheet, which I'll put on the thing, is lesson 41. Oh, never mind. Number 6. Let's go to that one. Lesson 41, number 6. And I said to look at the example on that. Okay. Cosecant of negative 330 degrees minus secant of 390 degrees. Let's just kind of do this together. So negative 330 degrees, if we were to like kind of plot that around, it would go around here like this, and it would come out to be 30 degrees, right? So this was negative 330 degrees. We know that it's going to be square root of 3 over 2 and 1/2. Okay, cosecant is the opposite of sine. So it's just going to be 2. I just went really fast on that. Did you guys get that or no? Because it's the opposite of sine. Let me just double check myself since I'm trying to go fast. Yeah, so it's going to be cosecant is the opposite of sine. Sine would be its inverse operation. And so this would be sine, and then we flip it to be cosecant, so it's 2. So sine would be 1/2, the cosecant is 2. Okay, now we have to do the 390 degree thingy. So we're going to go around this time. We're going to go around 360, and we're going to do another 30. We're going to end up at the same place. Isn't that convenient? Okay, so it's going to be the flip of the cosine. So it's going to be 2 over the square root of 3. So we're flipping the cosine for secant. And then you just need to find your common denominator and all that kind of stuff. We can rationalize this first, like this. So we get 2 minus 2 root 3 over 3. And that's going to be, is it 1/2 because 1/2 over 1? Which one 1/2? Why is it 2? This one, why is this one 2? Because it's going to be whatever the cosecant is 1 over the sine, right? So it would be 1 over 1/2. And then you flip it and multiply. But you can just flip these over and they're going to be the opposite. Like when I'm finding the secant of 390, I find the cosine of it, which is 2 over the square root of 3, and then I flip it. You just flip those. The cotangent is the flip of the tangent. The cosecant is the flip of the sine, and the secant is the flip of the cosine. And so your final answer is this. There you go. So in the book, they'll do like this. But really, you just can flip this around, whatever it is, and you'll get that. All right. We're booking it now. Oh, I skipped one, and I said that one you can look up in your book. It's lesson 44, example 3. That's what I have, example 3. So you're just going to look at the book on that one. I don't think I could find any good examples. Okay, number 19. Let's just look at these real quick. I think they're super easy. This is lesson 37, number 7, and all it is find the midpoint. So you can look at it real quick. 37, 7. It says find the coordinates of the halfway point between -4, 7, and 3, 2. So you're just going to use the midpoint formula. You would just say -4 plus 3 divided by 2. That's your x coordinate. Your y coordinate. This is really easy one. 7 plus 2 divided by 2. So you guys can get that one. Don't miss that one. All right, that's just the midpoint formula. Just put it in. Okay, and the last one on the test, here we go, is lesson 45, number 10. Let's see what that is real quick because we're down time. It's just write the equation of a sine curve. So look at that. Let's write that real quick. You guys go ahead and write in the equation of the sine curve, and then we'll be done, and then I'll put the test up in the study guide on the webpage. Does anyone want to type that in? Okay, that's not bad, but it would be, okay, now it's a sine curve because you're starting at 0, 0, right? It's a sine curve because you're starting here, and then it's going to go like this. But it's going down first, so it's going to be negative, and it's going down 10, so it's going to be -10. Put your negative out in front. Sine of theta. These start out really easy, but someday they're going to get really, really, really hard. But for now, enjoy the easiness of it. And that's it. And the one on your test is very, very, very similar to that. All right, so that's it. We did a lot. You should be really prepared for your test this time. So maybe like some 100% would be really nice. Okay, so I'll see you guys. Have a good Thanksgiving, and we'll see you the Monday after Thanksgiving. All right. See ya.
You are currently the only person in this conference.
Good one. Okay, you write it. All right, we'll see you.
She usually tells me if she's not coming. It's probably.
Go to the store and buy